In this video, I'm going to go over this question. This was the last question in the 2024 Pure A2 WJEC maths paper. So Robert wants to deposit £P into a savings account. He has a choice of two accounts. Account A offers annual compound interest rate of 1%, whereas B offers a rate of 5% for the first year, and then an annual compound interest rate of 0.6% for each subsequent year. We're told that after n years, account A is more profitable than account B. So obviously the amount in account A, assuming nothing is taken out, is going to be greater than the account value, so the amount in account B. So what we're going to do is use compound interest formulas to work this question out. So for A, the amount of money that is going to be in the account after n years is going to be the principal, P, times the multiplier to the power of n. So if the compound interest rate is 1%, then you can work out the multiplier by doing 100% plus 1%, which is 101%, which is, as a decimal, 1.01. So the amount in account A after n years is P times 1.01 to the power of n. However, for B, the amount in the account after n years will be P times, well, for the first year, there's an increase of 5%. So to work out how much will be in the account at the end of the first year, it would be P times 1.05. And then you've got another n minus 1 years if we want to work out how much will be in the account at the end of n years. So the 1.05, that accounts for 1 year, and then it's 0.6% for every subsequent year. So the new multiplier for those n minus 1 years is going to be 100% plus 0.6%, which is 100.6%, which is just 1.006. So we're going to have 1.006 to the power of n minus 1. So what we can now do is write an inequality, because we know that the amount in account A must be greater than the amount in account B. So very simply, we get 1.01n P, that's just the amount that's in A, is greater than 1.05 P times 1.006 to the n minus 1. But what I would notice about the right-hand side is that if I had, for example, 2 to the n minus 1, that would just be 2 to the n divided by 2 to the 1, or 2 to the n divided by 2. So I can rewrite the right-hand side as 1.006 to the n divided by 1.006. So I could also then divide both sides by p, so that I have 1.01 to the n is greater than, and I can just do this division here, 1.05 divided by 1.006. So I'll just get my calculator. I'm going to leave it as a fraction, so 525 over 503. That's times by 1.006 to the n. I'm now going to divide both sides by 1.006 to the n, so that on the left you have 1.01 to the n divided by 1.006 to the n is greater than 525 over 503. Now, if I had a to the n over b to the n, that is the same as a over b all to the power of n. So the left-hand side is going to be 1.01 over 1.006 to the power of n, and that is greater than 525 over 503. Now 1.01 divided by 1.006 is 505 over 503. So we have that on the left-hand side. Now, to deal with the power of n, I can take logs of both sides. I could take natural logs, there's no problem with doing that. So I'm going to take natural logs of both sides, because obviously the log function is an increasing function, so it's going to preserve the inequality. I can then use a third law of logs to bring the power of n down. So we have n times natural log 505 over 503 is greater than natural log 525 over 503. And finally, we can divide both sides by log 505 over 503, because obviously that's 505 over 503 is greater than 1. So this will be positive. So if I divide both sides by the logarithm, it will preserve the inequality sign. So we finally have n is greater than ln 525 over 503 divided by ln 505 over 503. And we can just work that out. Yeah, so you could put it in as fractions or use a divide sign. It's up to you. And I get 10.787 or thereabouts, let's say 10.79. Now, you can only have a whole number of years. N is greater than 10.079. Therefore, the least value of n is n is 11, because n is greater than 10.79.